Imagine spending years traveling through the endless darkness of space. No sky, no familiar sounds, just the hum of your spacecraft and the distant memory of Earth fading behind you. What does that do to the human mind? Beyond radiation, microgravity, and survival risks lies a frontier we understand far less. The frontier inside the brain. Deep space doesn't just test our bodies. It rewires our perceptions, reshapes our emotions, and pushes cognition to limits no human has ever experienced long-term. As missions to Mars become real, and interstellar travel shifts from science fiction to engineering challenge, one question becomes crucial. How will the human mind survive the journey? This is the story of the cognitive impact of deep space travel. A journey not only across the stars, but deep into ourselves. The first challenge is silence, a silence deeper than anything on Earth. Astronauts describe the soundscape of space as eerie and unnatural. No wind, no birds, no distant traffic. Just mechanical noises and your own thoughts echoing louder than ever before. Isolation inside a spacecraft is total. Your entire world shrinks to a metal tube no larger than a small flat. Every wall becomes a boundary. Every room becomes a memory of the life you're leaving behind. With no natural cycles of day and night, your sense of time begins to distort. Some astronauts report feeling like days blur together. Others say time stretches endlessly. Without Earth's colors, smells, weather, and variety, the brain begins to hunger for stimulation. This sensory deprivation subtly alters mood, memory, and emotional regulation. Even communication delays, minutes long on Mars missions, affect social connection. Every message becomes a one-way conversation, and loneliness becomes a constant psychological pressure. Deep space missions place the human brain under relentless stress. Every task matters. Every mistake could be fatal. Astronauts live with continuous awareness of life support systems, radiation exposure, and mission-critical procedures. There is no off switch. Stress hormones rise. Decision-making becomes more complex. Cognitive load increases as the brain must track hundreds of small tasks in an environment with zero margin for error. Sleep becomes fractured. Microgravity alters melatonin cycles and disrupts dreams. Long-term sleep debt chips away at executive function, the ability to plan, reason, and stay emotionally stable. Some astronauts report increased irritability. Others describe moments of emotional flatness, where feelings seem muted or delayed. Inside the spacecraft, small conflicts can escalate quickly. Privacy is nearly impossible, and the brain must constantly juggle vigilance, fatigue, and responsibility unlike anything on Earth. This pressure cooker forces the mind to adapt or struggle. Mind-bending realities, perception, and hallucinations. Space changes the way we perceive reality. Without gravity, the brain's internal map becomes confused. Up and down lose their meaning. Your visual system constantly recalibrates. Objects float silently, defying a lifetime of physical expectations. During long missions, some astronauts have reported flashes of light behind their eyes, caused by cosmic rays passing through the retina. Others describe hearing faint sounds that weren't there. A few have experienced dreamlike distortions during extended isolation. And then there's the phenomenon known as the overview effect. Astronauts seeing Earth from above experience deep emotional shifts, awe, vulnerability, and a profound sense of unity. But deep space goes beyond even that. Imagine months with no planets, no landmarks, no horizon, just blackness. Psychologists believe this sensory void may trigger altered states of consciousness. Some may feel an overwhelming sense of insignificance. Others may experience disconnection from reality. In extreme cases, hallucinations could emerge from a mixture of isolation, stress, and neural strain. Space confronts us with perceptions the human brain was never evolved to handle. But the human brain is not passive. It adapts. It rewires. It evolves to survive. In microgravity, cerebrospinal fluid rises toward the skull. This shifts brain shape, compresses regions linked to memory and spatial orientation, and changes how neurons fire. Studies show that long-duration astronauts develop measurable structural changes in white matter. New neural pathways form to compensate for the absence of gravity. Balance systems reconfigure. Spatial awareness adjusts. Even vision can be altered long-term. Some effects reverse when astronauts return to Earth. Others appear to linger for years. These adaptations raise a profound question. If deep space rewires our brains, what kind of humans will return? And how will these changes influence future interplanetary explorers? Deep space travel may demand a new form of cognitive resilience, one humanity is only beginning to understand. To survive long-duration missions, NASA, ESA, and private space agencies are creating new psychological support systems. Virtual reality simulations replicate natural environments. AI companions provide emotional and conversational support. Habitats are being redesigned to reduce stress, incorporate circadian lighting, and create more personal space. Therapeutic protocols focus on meditation, cognitive training, and emotional grounding. Future crews may undergo psychological conditioning years in advance. Some scientists even propose genetic or pharmacological enhancements to maintain cognitive function during deep space travel. Autonomous AI could handle high-pressure decision-making when humans are fatigued. Robotic assistants may reduce workload and prevent burnout. And new forms of community culture, built for isolation, may shape life aboard interstellar vessels. But these innovations raise ethical questions. How far should we alter the human mind for the sake of exploration? Where is the boundary between adaptation and transformation? And what will humanity become as we step into deeper and darker regions of space? The silent frontier. Deep space isn't just distances and danger. It is a psychological frontier more profound than any physical challenge. It pushes memory, emotion, and perception to their limits. It reveals the fragility and resilience of the human mind. As plans for Mars missions accelerate and visions of interstellar travel inch closer to reality, understanding these cognitive transformations becomes essential. Because the story of deep space travel isn't only about spacecraft, planets, or distant stars. It's about us. It's about how the journey changes the traveler, and how exploring the cosmos forces us to explore ourselves. Thank you for watching. This is 60-second knowledge extended, because knowledge doesn't stop at 60 seconds.
Thanks for watching. This is 60-second knowledge now extended, because curiosity doesn't stop at 60 seconds. Subscribe on YouTube and follow us on TikTok.